In this first exercise, we're given a set A with 4 elements, A, B, C, D. And on this set, we are defined 2 correspondences, which are given as a subset of both of them, S and R, are subsets of A times A. And then we have to obtain a certain set of elements of it. Okay, let's begin with first, right? First of all, we need to write down the matrix, the binary matrix of these 2 correspondences. So we have R here, okay, and we write the table like this, where the first in the columns we write the first elements of the pairs A, B, C, D. Sorry, in the rows and in the columns we write the second elements C and D, right? And what we have to do is we have to write a 1 for every pair that is here and a 0 for the rest. So for instance, BB is here, so there's a 1 here. BC, so there's a 1 here. AD, there's a 1 here. And DB, so there's a 1 here. And all the rest of the elements are zeros. So these are zeros. So this is the binary matrix of S, of R, sorry. This is S. Do the same. A, B, C, and D. And there's AB, so 1 here. CA, 1 here. DA, 1 here. The rest, all zeros. All right. Okay, what is the multigraph associated to this? Well, the multigraph for R is given by this. Let's draw the elements. So here's our 4 dots. So I'm going to represent the elements. So let's say that this is A, this is B, this is C, and this is D, for instance. So we have BB, so there is a loop here, okay. Then there's also BC, so there's an arrow like that. Then there is AD, so there's also an arrow like this. And there's DB, so there's an arrow in this direction, okay. So this is the multigraph of R. And the one of S is, again, we draw the elements, okay, A, B, C, and D. You can put them in any order you like. And then AB is an element, so there's an arrow going from A to B, okay. And you also have CA, so there's an arrow going down here, and DA, another arrow in this direction. So these are the multigraphs of these 2. Now, what the domain and range? Domain of R is just the set of the first elements that appear here. You have A, you have B, and you have D, right? And for S, you have A, you have C, and you have D. About the range are the second elements. So you have B, you have C as the second element, and D. And that's it. And for S, you have A, B, and that's it, because the other one is A as well. So these are domain and the range of both. Okay. Now we need to list the inverse of these relations and the corresponding domains and range. Right. So I'm just going to copy the statement of the problem here, just to see it at the same time. Okay. As we do it. All right. Then B is R minus 1. What is R minus 1? Well, it's just, we have to reverse the pairs. So BB is the same. Then the other one is CB, right? The other one is DA. And the last one is BD. Okay, the domain of R is R minus 1, sorry, is the range of R, okay, which is up here. BCD, you can see that is the first elements, B, C, and D, right? These are the first elements. And the range of R minus 1 is the domain of R. Okay, the domain of R is up here and coincides with the second elements. So you have B, you have A, and you have D. Right? These are the three elements. And same for C, right? C, the inverse is just BA, CA, and oh sorry, BA, AC, and AD. Okay, these are the reverse pairs. And the domain of S minus 1 is the range of S, okay, as it is written here, so it's AB, right, AB, and you can see B here and A here, okay, and the range of S minus 1 is equal to the domain of S, which is up here, right, and this is the domain and this is the range, and is A, C, and D, right, A, C, and D, the second elements in this case. That's it.